All right, we're going to be solving a bunch of problems that require factoring. This is a typical problem. It's a little ugly, but it's easily doable. Whenever you want to solve a problem by factoring, what you must do first is set it equal to 0. And that's because we're going to use the zero product property in order to solve. So what I'm going to do first is add 4h to both sides, and that will give me this problem, 5h cubed plus 31h squared plus 4h now equal to 0. Now what we're going to do is we're going to factor in order to solve. What you want to do first is see if there is a common factor with all three terms, in which case there is. There's an h in common with all three terms, and that's it. So you pull out the h, and that leaves you with 5h squared plus 21h plus 4, all that quantity, times h equal to 0. Now factor within that parentheses. What you have here is a defoilable problem, but not an easy one. So what you could do is you can go to the side and write out all the factors for 5h squared and all the factors for 4, and then do as many combinations as possible. To save some time, we're not going to do that. We're just going to say that this factors out to h times quantity 5h plus 1 times quantity h plus 4. And now that's equal to 0. Now we have three things being multiplied together to give you 0, and we apply the zero product property in order to give us our answers. Now the reason why we can't just divide an h out is because this is a variable. We couldn't divide that out in the original problem because what that actually would have done is eliminate a possible answer, and we're looking for all possible answers. So what we do is we set each thing equal to 0. So we're going to set h equal to 0, 5h plus 1 equal to 0, and h plus 4 equal to 0. 5h plus 1 equals 0 means you subtract 1 from both sides. Divide both sides by 5. And there's your second answer. Our first answer was h equals 0. We didn't have to do any work there. H plus 4 equals 0 means you just subtract 4 from both sides, and that gives you an answer. So we have three answers, 0, negative 1/5, negative 4. So our solution set is 0, negative 1/5, and negative 4. What we could do to check this answer is plug each one of these into the original problem and see if we get a true statement, in which case we will. Now on to the next problem. We have a pretty simple problem. It just looks ugly. What I have here is I have a parentheses with an x minus 5 inside, and I have actually two of those. So what I'm going to do is I'm going to let y equal x minus 5. And the reason why I'm doing that is because if we substitute y for x minus 5, it gives us a much easier problem to look at. So you would just defoil that, factor that out. And substitute the x minus 5 back in. So we're going to turn these parentheses into brackets just so it looks nicer. Y is x minus 5, so I have x minus 5 in parentheses minus 3 and x minus 5 in parentheses plus 2. Get rid of the parentheses, combine like terms. X minus 5 minus 3 is x minus 8. X minus 5 plus 2 is x minus 3. Setting them both equal to 0 would give us an answer of 8 and positive 3, so our solution set is 8 and positive 3. And of course you can plug both of these into the original equation to see if it gives you a true statement, and it will. So that's that. Now we're finally going to do one more problem that involves factoring by grouping. And here it is. The tricky part about factoring by grouping is if you can't factor by grouping the first two and the last two right off the bat, then you need to do some work. So let's group the first two and the last two, keeping in mind this is a plus negative, so keep that in mind. You can't just throw the negative outside the parentheses. If you group the first two and the last two, what you're looking for is things that you can factor out of each parentheses individually. I can factor a 2a squared out of this first parentheses. So I do that. That leaves me with a plus 3. I can factor a negative 8 out of this second parentheses, and that leaves me with a plus 3. Now what I have on the left side of the equal sign is I have two factors that are exactly the same. If these were not the same, then I would have to rearrange this problem in order to give me answers that would do that. Perhaps I might have to rearrange these so I get a difference of squares situation, or maybe I have to rearrange them to get a perfect square situation. In this case, it all works out anyway. So I have an a plus 3 in common with both of these factors, and I'm going to pull that out. What that leaves me with is 2a squared minus 8. Now you don't just stop there and solve. You see if you can factor out any more, in which case I can. First off, I can factor a 2 out of that parentheses. So I'm going to take the 2 and bring it all the way out front. Now what I have inside the second parentheses is difference of squares, so you factor that out further. So I have a minus 2, a plus 2, that equals 0. Now I can solve. Okay, obviously this one, since it's just a number, can be completely you can just get rid of that. So get rid of the 2 because it's a number. We didn't get rid of the other one before because that was a variable, but you can divide out a number to make it go away. You can't divide out a variable to make it go away. So what we're left with is a solution set of negative 3, positive 2, and negative 2, because if you plug a negative 3 into the first, you get 0, 2 into the second, negative 2 into the third, gives you 0. It all works out. We're done.